How's the volume there? Is that okay? People in the back? Yeah, thumbs up? Okay, excellent. Got a ton of material to get through, so I'm going to talk very, very fast. I realize it's the end of the day. Hopefully, I can give you guys some energy, and we'll get through everything that we've got here. Obviously, Multipath Tcp. The quick, who the heck are we? I am two people today. My colleague, Catherine, couldn't be here today, but she is absolutely instrumental in this, so I'm going to be giving, as best I can, both of our perspectives. We are from a little company in Chicago called NeoHapsys, who was recently acquired by Cisco, so we're still getting used to that. She is the RFC geek. She is the one who sits down and reads RFCs for fun. I don't understand that. I'm more on the application side, and the conversation between the two of us really turned into this talk. This is going to be the thesis for today, that Multipath TCP changes fundamental assumptions about how TCP works. And that wording is very carefully chosen. I'm talking about assumptions. Multipath TCP isn't breaking things. It isn't a vuln. It isn't an exploit. It isn't a broken protocol. It just challenges assumptions that we've made in network that have previously been true that don't necessarily need to be true in the future for some use cases that we actually really care about. And I noticed there's a little asterisk there. That asterisk goes to kinda. If we're not talking about layer 4, everything's totally the same. So we can constrain our view a little bit. So lower than layer 4, kind of OSI model type, all good. Above layer 4, all good. Layer 4, TCP layer, buckle up. Let's get right into an example just to illustrate the level of unusualness that we're talking about. Raise your hand if you know curl. Good, most people? Okay. Pretty simple tool. We should all have at least a basic understanding of what it does. Curl to a website, get the default page for a web server. Nothing weird there. The tools look like they're behaving the same. Wireshark, another tool that we like to use. Go follow the stream. What do we see? The GET request, perfectly reasonable, normal GET request, and no response whatsoever on the stream. But it was here. It was in the console. We know that the application stuff is working. Everything seems to be working, but our tools are lying to us. OK, netcat. Who knows netcat? Awesome. OK. Simple as we can possibly get if we're doing TCP stuff. Please work reasonably. Netcat to a server. This happens. This is netstat. Instead of getting one connection opened up, we get 10 to multiple different IP addresses. Notice IPv4 and IPv6. All of these things being done for us. Like, what the heck is going on here? If you don't understand Multipath TCP, this makes no sense. Like, this is just bizarro world. So, why do we see that? We have to talk about Multipath TCP. But to talk about Multipath TCP, we have to talk about TCP. Why are we doing this? What's the point? Current TCP is rather limited, and I feel a little bit dirty saying that, given how much the internet has grown and the kinds of things that it can do and the capability and the flexibility and things like that. But the truth is, it doesn't serve some use cases that are becoming important now and are going to be more important in the internet that many people envision 5, 10, 15 years from now. Things like high availability, being able to have uber uptime or extraordinarily high bandwidth, being able to pull together lots of heterogeneous links to do things with, multi-homing, if you've got mobile devices that are going to be on multiple different types of networks, and then kind of the extreme of multi-homing, which is mesh networking, which is at any given time you don't quite know what your route ought to be, and you've got to have some way to effectively use all of those, and we don't want to burden application code with that kind of knowledge. So here's Multipath. It is an extension to TCP that adds that functionality, that adds capabilities that make that functionality possible. And it works over existing infrastructure. So the important thing is that Multipath TCP does not replace TCP. Multipath TCP is TCP with a few extra things added on. But not much understands it. And why I'm talking here today is that not much understands it, including security tools. So all of that weirdness that we were talking about early on, that carries over into your security tools. So if they have to reason about this and make important security-related decisions about a protocol that they don't get, we've got some problems. All right, had to put this slide in because people misunderstood where we were at. Going back to the thesis, it's culture shock. It's not a broken protocol, it's a cool protocol. It's a useful protocol, we like it. We like MPTCP, we want it to succeed, so please don't take away, kill it with fire, or kill it all the time, or whatever. It's a useful protocol, there's a reason it's being developed. So, we want it to succeed, we just want to put the word out and get people thinking about what this changes. Here's the outline for the rest of the talk. A little bit of background, technical introduction, getting just as far into how Multipath TCP works to understand why it works that way. The key security effects, the ones that we've picked out as seemingly the most important going forward. Some effects on perimeter security, what this changes. We kind of thought that we had perimeter security nailed down in the late 90s, not so much anymore. Network management, if you own or manage or set policy for a network, what does this change? What do you have to be thinking about? And then just a little peek into once a protocol like this becomes widespread, what does that do? What does that enable? So what got us thinking about this in the first place? This is Kate sitting around with her glass of wine reading RFCs for who knows why. She saw this. Apple in late 2013 makes a big fuss about this thing that they're adding. So she follows it up. This fellow, Olivier Bonaventure, Professor Bonaventure at a university up in Belgium, is leading a team who's doing a lot of this work. And he had PCAPs. PCAPs are awesome, you go take a look at those. And we saw the same failures that we were talking about earlier, right? Like tools don't do what you expect them to do in the face of this kind of traffic. And news outlets started talking about it, saying, oh, this is cool, and Apple is investing heavily in this thing most people hadn't heard of. The Register, for some reason, hates Multipath. I don't know, they always write bad articles about it. But ultimately, after that sort of media flurry, things kind of died down, everything went quiet. And we're like, wait, what? What happened? People are still working on this. Implementations are getting developed. It's getting pushed into devices. That initial flurry of information was putting it into iPhones. So where's all the quiet? What's the deal with that? We being security people are like, hey, new protocol, let's take a look at it. Was anyone thinking about security on this? Two different things here. The security of Multipath TCP itself, the design of the protocol, the handshakes, all that kind of stuff. Yes, they were thinking about it. The protocol has some really thoughtful choices there, and for people developing these experimental things, they actually went and did something really, really cool, which is along with their RFC for the protocol, they released an RFC of their threat model. Like, we're designing this thing, here's what we think are the attacks, here's where we think we can protect against that, here are places that we can't. That's really cool. We need to encourage that kind of thing. However, that's not what we're talking about today. That is, protocol ODAs and things like that. No, we're talking about the context that Multipath runs in. That's what this talk is about. What a change like this mean for network security? Not a heck of a lot of talk going on that. So that's what we're talking about today. Ultimately, what does Multipath mean today? If you start seeing it on your network, when you go back to work next week, what is the significance of that? How can it affect things? What does tech like this mean in the future once we've sort of embraced this and, imagine a day when Multipath is used widely and IPv6 is used widely, like how does that change, mesh networking, mobile devices, blah, 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 all that kind of stuff. How does that change the way that we have to make security decisions based on network traffic? And then, of course, just to make sure that we're not completely full of shit, we're going to throw out some POCs and stuff like that that actually show the sorts of things that we're talking about here. Okay. This is the technical part. I know this is the management track. I promise to get just deep enough into it to understand the significance of the other stuff that's going on. TCP defines a connection as IP and port to IP and port. Technically port to port, but let's say IP and port and IP and port. Not between some abstract idea of endpoints. Academically, we could say, yes, it's from endpoint A to endpoint B, but realistically, it's IP port, IP port. So in the past, this was a distinction without a difference. Multipath TCP says, aha, we have the option of splitting out that abstract idea of an endpoint. Let's do it. So Multipath TCP connection is defined by a connection ID. That's it. If you can prove that you are part of a connection, then you're allowed to join in that regardless of wherever you're coming in from on the internet, whatever IP address you're coming in from, any of that kind of stuff. MPTCP is composed of plain old regular TCP streams with a little bit of other option on that. So it's all entitled. Multipath TCP is TCP over multiple paths. Characteristics. The folks designing this protocol, building the implementations, are looking for these three things. Backward compatibility. This is huge. You cannot make a change like this at scale without pulling teeth if it's not backward compatible. Multipath TCP is, and that's some of its strength, and that's also one of the reasons that we have to be talking about, okay, how does it affect things that we've come to take for granted? Performance, why bother doing it if the performance wasn't better? There are lots of cases that we care about where it really does have better performance, both in terms of maintaining a connection and in terms of amping up the capabilities of a connection. And in security, their goal was at least as good as now, and they've achieved that at the protocol itself. Here's what it looks like. Client talking to a server over a network. Client has a interface here, server's got an interface here, talking over one network. Looks pretty reasonable, just looks like TCP so far. But what if you have two networks that you can talk over? This is the classic mobile device scenario. Maybe you're over Wi-Fi, and you also want to talk over LTE or something like that. Okay, you can make that connection. And again, this could seem a little bit like just regular TCP, but here's the difference. In multipath, these two TCP connections contribute to one single logical multipath data stream where you can send any traffic over either one equally well, and the receiving server, which again has to be multipath aware, will correctly reassemble it. You can just keep on adding connections. If you want multiple TCP streams over here, you can just add those connections and stream the data, multiplex the data across those however you want. The sender of the packet chooses where the data goes. So you can choose to saturate network A and then switch over to network B. You can choose to stripe it across. There are any number of reasons why you choose those in different networking contexts. Multipath TCP makes that available and puts the power in the sender's hands. This is going to become important. As connections drop or get killed or time out or there's a problem with the network, this flow can keep going. The multipath session, the higher level logical session, keeps going as long as there's any of the actual TCP sessions there. In fact, it'll persist even if all the sessions die within a pretty reasonable window. You can just pick up and resume where you left off because multipath understands it's going to be dealing in networks where maybe that's a good thing to do. If you start getting slowness or anything like that, you can immediately resend data, and obviously if the server gets 2 copies of it, it'll correctly slot that in and move the logical window forward. So if this didn't make a whole lot of sense, or if this wasn't convincing, ultimately these are the scenarios we're talking about. For clients, mobile devices, devices with heterogeneous networks, devices that need to have those capabilities to make the best use of whatever networks are available to them. So seamless roaming, that kind of stuff. Data centers, high availability, the ability to fail over instantaneously and not even call it a failover, just keep the same TCP streams going, all of that sort of stuff. That's on here. So these are the 2 major use cases. Though just quite recently, I was reading some papers, and there is another kind of cool use case, and it's this. Rural networking where you have people who have no reliable network connections whatsoever, and they maybe have a patchwork of really questionable networking connections. Multipath now has some routing choices that will help with that as well. So this is being used. So it is a useful protocol. There are lots of people developing approaches to use it to solve some very interesting networking problems. How's it implemented? At a high level, this is just your regular TCP packet. TCP allows you to have an options header that you can stick other things in, extensions to the TCP protocol. Multipath TCP is one such extension, one such option. So option type, we are MPTCP, what kind of MPTCP packet this is, and a little bit of data which ultimately ends up being used to identify connections and things like that. It's in Wireshark right now. If you got a Wireshark from, say, the last 12 months or something like that, you just pop open Wireshark and look at a PCAP. We'll have some PCAPs later on, and it'll be right in there. So you can start playing with this immediately. High level, 8 subtypes. We care about a couple of them, so I'll hit those. MP capable. This is a host saying, I speak multipath. Feel free to speak multipath with me. MP join. I'm attempting to join an existing connection. And DSS, this is how it maps all of those different TCP sessions all into one. Add address, another one that will become important later. Says, this address also represents me as an endpoint. And remove address, I'm no longer available on this IP address. Please stop talking to me there. And a couple of others. So what's controlling this capability that we have? I should gesture less. I've broken it. There we go. OK. I'll hop around less. We have this capability to set up multiple connections. What controls that? In Linux right now, which is where the reference implementation lives, there's 2. There's one called full mesh, and there's one called NDiff ports. Remember, this is in the TCP stack. I said above layer 4 and below layer 4, stuff doesn't change. So applications get to take advantage of this kind of thing for free, which is one of the reasons that it's really important. NDiff ports, sort of an experimental, or sort of a testing experimental approach, basically says when the client sets up a connection to the server, it should also make additional connections to that same server on that same port. Looks like that. Not super useful. Maybe there's a few contexts in which it's useful, but mostly used for experimentation on devices if you only have one interface or something like that. Full mesh is where it gets crazy. Client talking to a server, they will connect on all IP addresses on all interfaces that they choose to advertise to each other. So if a client's got 4 possible interfaces available to it, and the server's got 4 possible interfaces available to it, then the connections start looking like this. And any of those links are perfectly valid for any slice of traffic that you want to send over the larger data stream. As a TCP handshake, that contains some of the initial keying information. That's where you say, here, I'm a multipath connection. Here's how to join later on and things like that. But keep this piece in mind. I'm going to keep coming back to this. The sender gets to make the choice of which network they want to use. Now, it can be the sender of the client side or any responses down that data stream from the server. But whoever is initiating a packet gets to make the choice of which of the available streams that goes down. For all of these details, we don't need to get super deep into them. We put a cheat sheet out. I'll have the URL up at the end where you can go get this if you want to kind of see everything quick 2-pager. So we're talking about this protocol. Basically, the question is it relevant? Do people see using this for important stuff? No one's really using it at large scale yet. This technology is very nascent. It's mostly being used for experimentation to prove the case that it can be used large scale. However, a couple of very interesting exceptions. iOS 7, it ships on every iPhone. It's used for Siri to be able to maintain that always-on connectivity, that immediate responsiveness, that quick failover, so that you have that seamless user interface. They put a lot of engineering capital into putting it on and then turned it on for that exact one system. And it seems like that was successful at something they liked doing because then in Yosemite, they shipped it enabled by default on all machines. Now, we did a test earlier today, and it doesn't look like it's being used for arbitrary traffic, but it is on the machines. It is enabled. That capability is there and ready to be turned on. So this is a huge engineering investment to put this technology out there, and it'll be interesting to see at what point they decide to go whole hog with it. And a couple of other experimental things here and there. Other kit. It's not just Apple working on this. Basically, we got Citrix, Cisco. Citrix sits in their NetScaler, full implementation of it. It's ready to go. Cisco, a bunch of their firewalls and devices and things like that understand it and can make intelligent decisions about it. The intelligent decision, in most cases, the default is just strip it, but it's there. Apple, obviously, big engineering effort. Oracle says they're putting it into Solaris right now, and the big IP is Multipath TCP aware, so it can do all of that kind of stuff. So a lot of people wagering on this, a lot of people seeing that this technology solves some problems that they're having. Not Windows. Microsoft, kind of par for the course, is a little cagey on sort of unannounced features. So this isn't surprising. I wouldn't read too much into this. If you wanted to get this working, if you wanted to play with it on your own, Linux, you can just go apt-get the packages. It'll work. apt-get, install, reboot, you are MPTCP capable, that's awesome. Don't try and go put it on Kali right away. I'd try something else first, play with it. It can work, you're just gonna have to mess with some things and it'll be annoying. But if you go to that effort, Kate tried it out and played and found that yes, once you get multipath working, Metasploit will very happily run all of its payloads and all that kind of stuff over multipath and do crazy things like that. So yes, really applications don't have to know about it to take advantage of it. This guy, I think also at the university in Belgium, made a really excellent Scapy implementation of all of this stuff. So if you want to play with it, you do not need to start from scratch. Highly recommend you check out his stuff. Our tools are just a thin veneer over top of that, so huge props to him. It's MPTCP Scapy on GitHub. All right, this is the meat of what we're talking about. Like, okay, cool, neat tech, so what? Here's what we've got. 4 main pieces. I'll just throw them all up here. Cross-path fragmentation. This is what we've been talking about. This is the whole point, is the ability to do cross-path fragmentation. Now, benign clients, rational, reasonable clients, are not going to do any of the crazy stuff that we've talked about. However, attackers can choose to do whatever they want as long as the receiving machine understands them, and that's where some of this comes in. Moving target, the idea that you can change IP addresses in the middle of a connection, potentially bouncing through multiple ones. A lot of tools don't expect logical connections to have different IP addresses within the lifetime of the connection. That's a little bit unusual. Connection resilience, anything that's based on trying to tear down connections by nuking them one by one, like sending RIST or something like that, Great Firewall of China type thing, that kind of goes out the window when you can just pick up where you left off as soon as you get any kind of connection, use it for the length of it, and then when it gets torn down, you've got another one ready to go. And then reverse connections. Get into this a little bit more later, but this is where we start talking about network architecture changes. So kind of, if you want to take away one slide, because of these 4 key security effects, if the approach to security requires any of these things, if you expect to see all the app layer stuff in the TCP stream, that's no longer going to work. If you expect to associate logical sessions at your application layer, or for if your web app is looking at, did the person come in on this IP, can we pin the cookie, any of that kind of stuff, that's not going to work anymore. If you're trying to close bad connections, basically play whack-a-mole with connections, that's not going to work anymore. And then finally, this other one, if you want to differentiate clients from servers based on the direction of the SYN, based on the direction of the traffic, that might not hold true anymore. And networking people start looking at me with a very worried look on their face when I say that. So if you rely on any of these, and not all security relies on this, so this is not the world coming crashing down. These are just assumptions that we have made that have historically been true that are not necessarily going to be true in the internet of the future. So how practical is this? Today, yes. These things will totally work. Demo coming up. But the problem is that client and server both have to speak multipath TCP, and as we talked about before, there's not that many multipath TCP speaking servers. So it's great. The attacks or the evasions, any of that kind of stuff will work, but nobody's actually vulnerable to them. But they're coming. in a full MPTCP speaking world, when we use it for things, when we expect it on a network, when our vendors support it, all that kind of stuff, then essentially this problem goes away, goes nearly to zero. The effective analogy here is like IPv6. When it first started coming out and Kit was showing up that supported it, and maybe our network devices didn't, or we didn't understand, we weren't looking for that kind of traffic, then something like the Slack attack becomes possible, where all of your devices speak IPv6, and someone could advertise, hey, let's create an IPv6 network. And all of your network starts talking over that, and you're not monitoring for that. So it's that same sort of thing that once as capabilities exist, if we're not using them legitimately, if we're not managing them, then attackers will say, hey, cool, let's use this. So we have to get there. Going forward. As I said, all these things can be partially mitigated, but there is some re-architecting to do, or there is this understanding of that we do want multiple flows to be able to coming in from multiple places, because that solves some real network problems that we're having, as we talked about on the mobile side, on the data center side, any of that. Packet sender decides where to send it. Again, normal, benign clients aren't going to do any of this crazy stuff, but just for a moment, let's not be a benign client. So what I've got here is, before I start the video running, this is a IDS distro, Linux distro called Security Onion that is really excellent. If you ever want to play with IDS stuff or really bootstrap yourself quite quickly, definitely check it out. What I'm going to do here is I don't know why no one else was having problems with that. All right. So super plain vanilla installation of Snort. I'm not picking on Snort. It was just on Security Onion, very easy to get set up. The only thing that we've changed on it is we've set up a signature to match basically a dummy payload that we're going to use here in a second. Tail the alert log. Anything that the sensor detects will show up here. For those who don't know, Snort's an intrusion detection system. We're going to send a payload here, MPTCP fragmenter. We're going to send n of 1. This is the degenerate case. This is regular TCP with regular HTTP, send a connection, and the idea says, hey, there's something malicious going on in your network. My signature picked up on this. Okay. Sending again. Talking to a multipath capable server, we send n equals 5. We're going to take our payload, we're going to split it up and multiplex it, basically dice it over 5 streams. Open up 5 TCP connections, send the payload, and tear down all the streams. IDS says, everything's cool. No problems here. Why? So if we go get the traffic here, looks like normal TCP, normal HTTP. But if we pick one of these out and actually look at it, pick one at random, how about that one? Or that one? Follow stream, here's what we see. Get/neodem. What that should say is get neodemo test, new line, host equals this, all that kind of stuff. It should be a full HTTP request. We see the response here, a response to an invalid request. This is because our payload was 40 characters or so. We sliced it by 5 pieces, and then each of those pieces went down just one path. At which point the IDS, if it's signature-based, has nowhere to match those signals. There is not enough context on any given path to be able to do that. And this is really just a traditional fragmentation attack, like from the late 80s, 90s, that kind of stuff. And Nmap says, hey, I can fragment in time. to smaller packets, slow down, don't provide middle boxes with the context to understand that there is something malicious going on. So that's fragmentation in time. This is fragmentation in space or across TCP streams. And it's effective. Perimeter security. Multipath TCP and firewalls. So this gets to something that I've alluded to, but we haven't talked about yet. It has the possibility to change things for perimeters. I will preface this by saying that what I'm about to talk about here exists in this spec. There are reasons for it to exist. There are some interesting scenarios. It hasn't been implemented yet. This may never come to pass, but if it does, boy howdy. How would you like an outbound incoming connection? Let's do this network diagram again. Client talking to server through a firewall. Looks good so far. SYN, SYNAC, okay. A couple extra options. We're talking MPTCP, ACK. No problem. On some future packet, this client can say add address. Remember we talked about those various types of MPTCP messages? One of those is add address, which says, hey, I'm available on another IP address. The internal host, call it the server here, has the option, is not required to, but may initiate a connection outbound to talk to the other host. Boink. And so the question right here is this new connection incoming or outgoing? From a data flow perspective, the initial client server were this way, but from a traditional, like the direction of the SYN establishes the relationship, this is an outgoing connection. This port actually typically is the same as this port, but it could be different. They're still figuring that out on the spec. So is this incoming or outgoing? And Catherine and I went around and around and around on this. And eventually we tried to decide whether is this semantics or is this actually a real difference. And eventually said, we can't come to a decision, use a kitten. Okay, so here's a kitten. And this is legitimate confusion. If something like this exists in your network, which could be useful for any number of situations, NAT traversal or any of that, do you want this to exist? Is this a good thing? But hey, it could be there. Let's be aware of it. Which gets us to network management. Be aware of it is really the point going on here. If your tools don't understand it, they can't help you make the security decisions that we would want to make when we're looking at content, when we're doing inspection of traffic. Here's an extreme case. This is Firefox grabbing one web page from one server. All this kind of stuff. This is the extreme case. This is the mesh networking with multiple addresses. And again, normal rational clients won't be doing all of this kind of stuff. But if you don't have the ability to condense all this down to the logical view that it is endpoint to endpoint rather than IP port to IP port, then you get something that looks like this. That exact same traffic, if you can at least cluster by IP address, and then if you truly understand multipath, this is what it looks like. It becomes very clear that it's this machine and this machine talking. So one of the defenses right now is awareness. And I feel so bad with this right now that I've got people and technology based on a keynote this morning, but I will try to avoid the traps earlier. People, you're here, you're learning about it. Educate yourself. If this is coming, start making decisions in advance. Technology, talk to your vendors. Do you support this? Do you want to support this? What are use cases where this would be useful? If this starts flowing through middle boxes that you care about, are they going to know what to make of it? And then look for use. We talked a little bit about IPv6 earlier, that it started going into data centers, it started going into devices, and we kind of had this idea that things were adding support for it, but we may not have known that immediately. So look for if it's being added to devices, look for if it's actually being used in your network. And then finally, architecture. There are some cool uses of this technology, but maybe you don't want it used in all places. So maybe you decide, hey, the right solution for us is to terminate it at the perimeter. We like it, it's going to be useful, we'll bring it in, and we just terminate it in the same place that we terminate SSL and treat it as one of those things that we need it to go away for us to do certain pieces of the network. And then maybe you fan it out again farther in your data center or to other separate sites, things like that. So there are some reasonably simple architectural choices you can make if you decide that it's maybe too much chaos for certain parts of your network. Speaking of support, we have a scanner that will be able to scan open ports. It's not going to try and replace Nmap. You tell it open ports, and it will talk to those ports and see if the underlying machine speaks multipath TCP. Basically, it tests the device for apparent support. Does it claim to support it? And then it tests it for actual support by trying to open up a multipath connection. Some devices, beware if you start going and looking at this stuff, there's lots of middle boxes or other firewalls, that kind of stuff, that will just blindly echo packets, echo TCP options back at you. We talked about the Great Wall of China, the Great Firewall of China. If you try and scan it, it will just blindly echo TCP options. So you actually have to test for real support, not just advertised support. Basically, SYN, ACK, join with a random invalid ID here, and a server that actually understands MPTCP will say, hey, you've attempted to incorrectly join an MPTCP session. One that doesn't actually support it will say, okay, hey, it's a valid TCP session. That's all I know about. Cool. So that tool's out there if you want to start going through your network and saying, hey, what kind of boxes do we have out there that support this? Stripping, talked about this earlier. If you want to take advantage of it in some places but not others, you can proxy and terminate it. That's a perfectly reasonable choice. If you decide that just for whatever reason you need to kill it, the firewall rules are IP tables, strip options 30, or iOS strip options or TCP options 30/30 clear. That will make it go away. This turns out to be the default on a lot of Cisco gear, so you may not even have to make that change. But that's basically, this is the kill it and we'll deal with it later approach. Active network security. Now we get into talking a little bit about privacy and things like that. Multipath TCP is even more resistant to network tampering, redirection, that kind of stuff than TCP. That's not a huge goal of it, but just by way of doing things. Essentially, if you want to man in the middle traffic, you have to be there on the first connection. And you've got to perform some non-trivial calculations to maintain the state of all the different connections.
State is expensive to track.
Yes, I agree with you. I have some of that concern. The folks who are actually developing the protocol, of which I am definitely not one, they are doing some things to manage that, but I think that is an open question that will really matter for adoption. This, I think, is one of the reasons that MPTCP's got an interesting shot. It's moving power to that internet ideal, to that kind of IETF ideal of power to the endpoints, that the network should be able to exist and be in flux and maybe not be trusted, but we have our client and our server should be able to talk in a way that works for them. One example being, if you got your ISP and your cellular company and you're splitting data across that, you don't necessarily have to trust either of them with all that data. You can split across it. And if you're talking across multiple networks that don't necessarily trust each other, then there are possibly some gains there in privacy. Split trust crypto, I'm not sold on this, but some people are talking about it. If you are conducting different parts of the negotiation over different protocols, is there a gain there? Is that something worth doing? We'll see. People are working on it. And then multipath agility. I think Moxie talks a lot about crypto agility of who do we trust for how long, why. The same thing coming to network paths. We can make choices in the middle of a connection without actually affecting the services that are riding on top of us. And various people are doing research into the privacy efforts on here. Conclusion, multipath is awesome, and it's coming. If not explicitly MPTCP, this is the one that looks like it'll probably make it, but a technology that serves all of these network needs and network purposes. So something is coming. And traffic inspection is going to get harder. Just the act of trying to get machines physically together to talk and reassemble data when some of that traffic has gone over separate networks is you end up being limited by geography, speed of light, those sorts of things. The logistics of moving information about what we've captured from partial paths to a central location, that makes it harder for active network attackers, for people monitoring networks, all that kind of stuff. And ultimately, we're talking about this now. Keep talking about it. If you're interested in using this tech, look it up. If you're interested in managing this tech, start talking to vendors, that kind of stuff. Try it. We put some PCAPs out there. Here's a challenge that if you're interested in this kind of thing, or if you want to try out a little bit of Scapy, kind of dip your toe into it, the ultimate solution is about a dozen lines of Python or something like that, so this isn't a huge investment. The solution is out there, just don't peek if you want to do it yourself. But please, play with it, get involved. And if you got questions, yeah, hit me up afterwards. So there you go. Questions?
So you see, there's a reason why I invited Patrick to come over. Questions, actually. I mean, it has been a long day in the saddle, kind of, as we say in cycling. But probably he's happy to answer any that might arise. There's one in the back.
Since asymmetric routing on its own is already sort of a headache, do you have any experience with asymmetric routing and Multipath Tcp? How applications support that, or are they still able to run?
So I'm not super familiar with asymmetric routing, so I can't give a precise answer to that. Are you talking about like that outgoing traffic comes in one way and incoming traffic comes in the other?
Over different ISPs, since you essentially mentioned.
So yeah, this is it. This hides it from the application, so applications don't need to know anything about this. One of the questions is, are there going to be APIs for applications to influence the decision that their route managers take? Probably to be determined, one of the questions. But ultimately, this works, and I think the example of once you get it working on, say, Kali or something like that, an application is very particular about being able to manipulate the network at a low level and things like that, like Metasploit, that just works. So if your question is it going to cause incompatibility? By and large, no. If the question is it going to cause potentially weirdness in how we manage the network or how we monitor the network? Absolutely.
Many mobile providers have NAT gateways for the devices. And does it work behind that?
Yes, and that's getting that to be the case has been a little bit of a headache for the people implementing it, because ultimately, if you're going to be able to traverse a NAT, you have to let the NAT rewrite some packets, and they want to have this be as resistant to manipulation. They want to the flows be as resistant to manipulation as possible, but NAT is manipulation. So there are pieces of the multipath header that they would like to check some, that they choose not to tolerate NAT. And yeah, it's...
If I start over Wi-Fi for my DSL provider,
Mm-hmm.
and then it says, okay, reach me to the NAT gateway. So how does the NAT gateway for my mobile provider is now that I'm the endpoint?
That part, I don't think, yeah. If you either advertise an internal network or if you advertise the address of a NAT that it's never heard of, it's going to come in, it's going to bonk off the NAT, and that connection just won't work.
But, I mean, the client won't know the address of the NAT or the external address of the NAT gateway anyway, so why should it ask for that?
Yes, I don't have an answer. I know you can start the initial connections to the NAT, and I was actually reading the other night about some of their NAT headaches.
Yeah,
I don't have
you're
a...
asking for an additional connection through the NAT.
Yeah, that one's not going to work. But I probably need to go do some more looking on whether there's any way, I mean, there's always stun and things like that to get to do NAT traversal, but then we're not talking about multipath anymore. So yeah, I don't think that that has a way to work.
Am I right in understanding that once Multipath TCP will be widely adopted, that this will provide great opportunities for Tor?
Yes, that was, I had a slide on it and I was debating putting it in there, but I don't want to invest too much capital yet in saying, hey, there's all these things like we could do and whatnot. But yeah, if you are connecting to Tor and then you're fragmenting your different, a few bytes here, a few bytes there, all the way through this, then it can even tear down the ability of doing like timing attacks or any of that unmasking. There are definitely people working on some of those ideas, and I hesitate to say that just that fragmentation is effective privacy, but it's certainly a piece of it. And a mesh network type thing like Tor, with the ability to do all the paths that you want at the same time, begins to get some really cool stuff.
Going to be expensive for the NSA to record traffic.
He said it's going to be expensive for the NSA to monitor traffic, and he's absolutely right. This raises the level of effort for people monitoring.
You mentioned to implement a proxy kind of idea.
Mm-hmm.
You want to hide some of your network of this functionality. So is this possible with proxies technology that's around the app, or do we need new proxy technology for that?
Somewhat possible right now. There's a bunch of papers. Actually, I had the rural Africa one up there, and there's somebody else did a paper on connecting rural Scotland, where basically they would have everybody connect to a local hub, and that used multipath TCP to try and reach out across a bunch of different connections. And it was a proxy that took normal traffic and then split it out over multipath to other proxies. And that was using slight modifications of existing proxy tools.
But then the proxy makes the decision, and not the sender.
So in the case that I was just talking about there is, yeah, they didn't want to have all of the people being served in the rural internet have to have multipath type stuff, and there's not a lot of multipath servers out there. So yeah, that's for kind of an infrastructure type view of it, but they use mostly off-the-shelf proxy tools.
I have so many questions, but probably because I don't know enough. How do you see, for example, the future of new attacks develop out of this new protocol? For example, like false attacks, for example, like advertising IP addresses, for example, which are not really mine, for example, as interface which I don't really own for this.
So for like a reflection attack for the ad, first of all, the piece there of actually having a server connect back to somebody else that isn't implemented yet, and that might be part of why it is, but in that case, you wouldn't get any multiplication, and I think DOS without multiplication is, in terms of the protocol and like, do we potentially see like there being gaping vulnerabilities and stuff like that? They've made some really conservative choices. I don't foresee anything really nasty coming out of the protocol, and they're really looking at what has TCP done, what are those lessons learned there, and let's make sure that we don't make any of those mistakes.
How well is the protocol equipped to prevent, for instance, hijacking a connection IP or something? I would just imagine that I would like hack into a server and then see, oh look, there is like this connection IP, and I can connect to my own server and basically shape the traffic and whatever else.
So at that point, you're basically talking about something that could just as well apply to TCP. Like if you're on the server, if you have the control of the server, if you can look at the TCP connection sequence IDs and things like that, at that point you can just hijack the TCP connections. Multipath is no better protected against already owning the machine and being able to access that. So in that case, that's one of the places where they said we want to be no worse than TCP. Any other stuff?